Dr. Bhaskar, Assistant Professor, Department of Computer Science and Engineering, Anna University, Chennai. Area of specialization is software engineering and database system. Guided more than 12 research scholars, published more than 40 national and international papers. He is a reviewer and editorial board member in international journals.
Welcome to the UGC lecture series in computer science. In this series of lectures, we have been looking at software engineering, and today's session I will be discussing on software project management. So, the overall content of this particular session is organized like this. Initially, I will be describing on the methodology of what this particular software project management is. Then I will be discussing on how we could transform all these methodologies into a very good set of network diagram. Then we will be discussing on from the network diagram how can we convert it to an independent path, from where we will calculate the critical path and we will go for an optimized cost calculation. Now we will understand the methodology of why we require a software project management. Whenever I hint on this particular term project management, immediately we may have to come across 4 important stages, that is planning, scheduling, monitoring and controlling. Any project requires quite a good amount of planning. That is, I should understand what are the different set of activities I am coming across and what each module and when it will be complete, and from where I will calculate the overall time period in which I am able to complete it. For that particular project planning, we will be drawing a network diagram initially. Then from that network we will be going for time estimation, which we will call it as network analysis diagram, from where we will be able to calculate the overall schedule for the project. Say if my customer asks me a question of when will the project be complete, I should be able to give it in a time frame. So this scheduling gives me an appropriate time within which I can complete the entire work, and further I can go with the time cost trade off and resource allocation and project control. Now we will start looking at the network diagram. So before looking at the network diagram, I will give you a short explanation on what is required in order to draw a network diagram. Having given a project, we will initially try to divide the project in terms of its modules. So for every module I am trying to assume with an activity label, which now will be referred to the corresponding description. So you now look at the table. So this table gives you a clear indication on a project that is to be developed has been brought down into these list of activities. Say design facility, prepare facility, select and order equipment, receive equipment, select staff, train staff, install equipment, test facilities. Before I start with the project, I am to align all these things, then I will ask my employees to work on such an infrastructure. So I am describing each and every activity with an activity label which is preceding it. So as a first column, what I am trying to insert is, for design facility I am labeling it as activity number A, and for prepare facilities I am making it as activity label B, and for select and order equipment it is C. So likewise I am trying to continue with all the list of activity descriptions that I have carried for a project, and finally to end with I have listed as activity H. Now when I am trying to understand on the same project, I should be able to plot, say I require a basic design and a prepare facility for the project. When I am designing it, at the same time I cannot prepare. So these are some set of constraints which out of experience every project manager might know. And when I am designing it, I do not require a preceding activity. Preceding are something that I am supposed to have completed it before. So when I am planning for a specific activity, then it means that for doing an activity A, I do not require any prerequisite, that is my prerequisite is null. So I can start with any time or I need not look at some project, some activity that is getting done. Whereas when I look at activity B, which is prepare facility, which is labeled as activity B, but then my prerequisite for it is A, by where I am ensuring A should be complete before I start with activity B. Likewise, for starting with C, A should have been complete. So from here, what can we understand is, to start with activity B and C, I should have done A before. So you can ask me a question of, for these two activities, I have the same prerequisite as A. So I understand that B and C can be done in parallel, it need not be sequential. So when I start with an activity from A to H, typically make an understanding that the projects need not be executed in a sequential fashion, it can be executed concurrently or parallelly. So that kind of understanding I get it with B and C activities, where B and C can be done in parallel since its prerequisite is just A. After the end of A, I can start with this activities. But for doing D, I have a prerequisite of C. For doing E, I don't have any prerequisite. So this case is something similar to that of A. So where I can start activity A and E in parallel, which does not require any prerequisites. F requires E to be complete, G requires both B and D to be complete, and H requires F and G to be complete. After I understand the clear description of such a list of activities, now I'll be able to give you a rough design of how this program structure has to flow. With the previous table that I have indicated, now that you have a look at this diagram. In this particular diagram, all these circles that I have indicated represents nodes, and all the line with an arrow mark indicates activities. So this represents an activity and this will be a node. If this is supposed to be a node, which will indicate either a start of an activity or an end of an activity. So if you consider A, for example, this becomes the start and this will be the end, and this is the processing time that I would require. By my understanding of the previous table, what I indicate here is A and E are two different activities which doesn't have any prerequisite. So I start with A here, I end up somewhere after some point in time. So now that I am not considering any time at all, and at the same time I can even start with E, it need not end at the same time of A, but then it is a different time. So E also takes some particular time and it is flowing through in the other flow diagram. After the completion of A, in the previous table I have indicated B and C are the two parallel activities which I am able to continue. So B and C are done in parallel. Now forget about this double lines also. It is going to be a single line and an arrow mark which will represent the activity. So B and C can be done in parallel. After completion of C, I can start with D. So after completion of C, I am starting with D. B and D joined together now makes an initiative to start with G. So I have joined B and D together by completing it as a node, and which will be the start for G. Same as in the other flow, after completion of E, I can start with F. After completion of F, I can start with H, but it requires G again. So when I complete with G and F, then only I can start with H. Two things that I would want you to hint in this particular network diagram. Point number one, by looking at this particular flow diagram, you can understand that every project will have only one start and one end. I repeat, a project will have only one start and one end. Now you can recall some of the aspects which I have indicated in the first software development lifecycle models. Although it has been divided into many modules like A, B, C, D, E, F, G, H, I integrate all the modules so that I will get a complete product. So by where in this particular flow after H, whatever that is being delivered will be the end product. Now you compare between the table and the flow that I have given. A preceding activity is null, E preceding activity is null. So I have started A and E together. B preceding activity is A, C preceding activity is A. So I have started B and C in parallel after A. After C I do D. After E I do F. After joining B and D I will get G. After joining F and G I will get H. So this is the understanding which we get it here. So this kind of drawing a network diagram. So this diagram is called a network analysis diagram, where we understand how the exact project is being handled and the program structure flows. Now I introduce the second set of item, which is the cost. So here I am representing initially in terms of time, then I am introducing one more factor which is called as a cost. So the first two list of activities is all known. So till this is what we have done. Anywhere I am not taking the description, activity description, which I have hinted at before. Now anything that I am to label is in terms of either A or B or C or D. So the preceding list of activities is given. Again, by out of experience of the project manager will try to understand how much time approximately every module would assume. So out of this experience I have gained saying A requires 9 weeks for it to get complete, and B takes up 14 weeks for the same to be complete, and C takes 4 weeks for it to get completed. So now you can forget about this preceding activity also. So what I have indicated in this table is just this. You can assume only these two columns, A with 9, that is A takes up 9 weeks for it to get completed, and B takes 14 weeks for it to get completed, and C assumes 4, D takes 6, E takes 14, F takes 6, G takes 5, H takes 2. Now another question which turns up, when I try to execute all these activities in a sequential fashion, that is from A, after I execute A, then only I can execute B, then I can execute C, like which if I am to execute all these activities in sequential fashion, then the time that I take for doing the overall set of activity is 60 weeks. So if you assume the first activity with the third, if you assume the first column with the third column, it would take 60 weeks if I execute it sequentially. Now after having introduced the second column, which is the preceding activity, we have clearly indicated here that for doing activity A and E, I don't require any prerequisite. So I can start up immediately the moment it has been given. And B and C can be done in parallel because its prerequisite is purely A. So likewise, when I do it concurrently, the time factor will obviously get decreased. So it will not be the same 60 weeks in time, it should be something less than that of the 60 weeks. So this is what is the understanding initially I get. We will have a short break, and after the break we will look at how we can estimate the time. Welcome back after the break. In this session we have been looking at network analysis diagram. Now that I was in a stage of explaining the timing factor. When I referred to the previous table where I have indicated all the activity times. So for A I would require 9 weeks, for doing B I might take 14 weeks, and for C 4 weeks, for D I have hinted 6 weeks, for G it is 5 weeks, and all these timings I have introduced in the network analysis diagram by itself. So what happens in this stage? The customer can ask you a question of, suppose if I start a project given a moment, when will I get the finished product? So that is what is the question that we are about to answer. If it has to be presumed in a sequential fashion, then we would have completed it in 60 weeks. That is what is the calculation which we got it from the table. But then we will not still assume the same 60 weeks, because all these projects are not going to be executed sequentially, and that too, since the project got divided in terms of teams, we will be able to make it up in less time. So when we look at this particular diagram, we could understand A and E are done in parallel, C and B are done in parallel, G and F are done in parallel, so that we could complete it very less time as compared to that of 60 weeks. Now you have to assume only the first block of this node. So these are supposed to be the node labels, 1, 2, 3, 4 are the node labels. This I have taken part of the table, but this 0, 0 would indicate the early start and late start timing. What is this early and late starts? Supposing that the project has to start at 0 by itself, when will I complete? So 9 weeks is the time given for activity A. If I start with 0, then it takes 9 weeks, so I will be able to complete it in a maximum period of 9 weeks for doing activity A alone. So for that specific reason, I am introducing a term which is called early start. So this early start is a start time wherein the customer, if given a chance, would start it early. Whereas the second time is called a late start time. What happens in case there is a slight delay in the project schedule being mentioned? So if the project has started with a little bit of delay, when would it get complete? So this timing can be indicated in two different flows. The first flow I will call it as forward flow. I will write it as forward pass. So during my forward pass, I hint you with a point wherein I will say I will consider the maximum of the time. I will let you know why I am writing this to be as a maximum time. Say for example, this project assumes 0 as its least time, and while switching from here to here, that is by doing activity A, it takes up 9 weeks. So early start for this would be 0, and this becomes the finish, the deadline for activity A. So here is where activity A starts, that is early start of A, and this becomes early finish of A. So this node is being the early start of A, and this node being the early finish of A. Likewise, this node being the early start of E, and this being the early finish of E. But assume the same node, this node again being the early start of C and B, because C and B starts from this specific node. So this becomes the early finish of A and will be the early start of these two activities C and B. I hope you can follow this particular thing. Now that if I would start at 0, A takes up 9 weeks for it to get completed. So when can I see that A is complete? So it is by 9 weeks. So as I have written in my forward pass, I will consider the maximum of the time and I will be filling only the first of the node, first box of node. So when I look at in the forward pass, I will be filling up only the first box of the node. So I will be doing only with this. When I have started at 0, activity A consumes 9 weeks of my time. So I will be reaching here by 9 weeks. When I reach here by 9 weeks, if that is supposed to be the early start of C and B, for C I require 4 weeks and for B I require 14 weeks. if I start C at 9, then I will be able to reach the end of C will be 9 plus 4, which is 13 weeks. And if at the same time I start with B also, that is 9, B consumes 14 weeks of time, so 9 plus 14, which is 23 weeks. So this becomes the early finish of C, this will be the early finish of B. So now when I look at the other activity which is following C, now this will be the early start of D and this will be the early finish of D. I hope you can understand. So if I am to start with D in the 13th week, D actually requires 6 weeks for it to get complete. So 13 plus 9, here I can reach it either at 19th week if I flow through this flow, or if I come across this path, I will be able to complete in 9 plus 14, which is 23 weeks, right. Just think but logically. My condition says I can start with G only after completion of B and D. When is this B and D? Totally it will be complete only after 33 weeks. Although if I flow through A, C, D, it takes a maximum of 19 weeks. I can reach here by 19 weeks, but then when I flow through A and B, it takes 23 weeks for it to get complete. I do understand once when I started with G, this requires a prerequisite of both B and D. So I can start with G only after 23 weeks. Now that is the specific reason why I have hinted with 23 here. Now going back, in the forward pass, I have mentioned a point which is called a maximum value. Now you can understand the maximum here of these two values following two different paths is 23. So that is why I have indicated maximum. So in my forward pass, still I am assuming the case maximum. So where and all I need to be comfortable or I need to be careful when I am drawing in the forward direction. Say when I am joining two different activities to a specific node, at that particular juncture I might have to fill this constraint, that is maximum. When it is a single node, I didn't have any problem, but then when two or more activities merge to a particular node, that is where this constraint need to be applied. So after reaching this place at 23 weeks, now that I start with G, which consumes 5 weeks of time, so 23 plus 5, 28, although I could reach here by 28 weeks, but there is another path which has to come across this way for starting G. So this can be very well treated as end of or early finish of G, but then this is not the only activity required for start of H. So I am looking at an alternate path also. Supposing that if I am to start with E at 0, E takes up 14 weeks. So I will reach E after 14 weeks in time. So 0 plus 14 which will be 14 weeks in time. So F requires another 6 weeks. So 14 plus 6 will be 20. So I will reach this place at 20 weeks, and if I flow through E and F, I will reach it at 20 weeks. And if I flow through this particular path, I will reach here by 28 weeks. Now the question of which timing factor to consider. If I consider the minimum time, will that be the right aspect to start with H? If you ask me this question, no. I will say an answer of clear no. Why? Because H can start only after completion of both G and F. So I cannot start with H until G is complete. So G will be complete only after 28 weeks. So that is why of any number of activities merging, I have asked you to calculate the maximum of the time. So now I can start with H after 28 weeks. So if I start with H at 28 weeks, H takes up 2 weeks. So I will reach the destination by 30 weeks. Now when you refer to the actual table that I have given, if I would have executed it sequentially, then I would have consumed 60 weeks of time. Now by doing this kind of workout, I have reduced from 60 weeks, now I can complete it by 30 weeks, which is almost 50%, that is half of it, correct. So this is the time which we wanted to plan, and we draw the network diagram. In summary, in today's session we have seen defining project management, and some of the factors that are important for this project management are planning, scheduling, monitoring and controlling. So as part of this session, I have asked you to plan and plot a schedule for it. And for the same plan and scheduling, we have started drawing a network analysis diagram, which we have done in detail. Some of the questions for this session: list the important factors of project management. Why is network analysis diagram important? How do you calculate the time using network analysis diagram? So this I want you to take a simple project of either library management system or whatever we are discussing in terms of student result management system, and I want you to complete. Thank you.